Yes, I welcome you all for this today's lab. That in this lab we are going to solve the dip and strike problems. So let us understand first what is mean by dip and strike. So you all know how the sedimentary rocks are formed layer by layer. Okay, they are deposited one above the other sediments and they convert into the sedimentary rocks. And because of the upliftment, plate tectonic movements, okay, these beds they come up and during this process they become inclined. Now, these inclined beds they play a very important role while constructing a dam or a tunnel or a reservoir. So, for example, if you see, you have learned in last semester the different cases how we have solved. Okay, suppose this is the ground surface and this is the dam. Yes, so this is the upstream side of the dam and this is the downstream side of the dam. And the forces acting on the dam are the self weight of the dam that is acting in the downward direction. Then this is the weight in the reservoir water and this R is the resultant of these two forces. Okay, and in this side, suppose if the beds are dipping like this, if the beds are dipping towards upstream side, then what will happen? And one more case I will show you so that you will get the difference between and what is the importance of this. Okay, suppose this is a dam and here the beds are dipping downstream side. Okay, and this is the reservoir. Here also this is the resultant force and these are the forces acting on the dam. Now suppose if there are this resultant force, okay, here in this case, in the second case, it is acting parallel to the bedding plane. These are called as bedding planes. And here, if you see, the resultant is acting perpendicular to these bedding planes. So your R direction is perpendicular. So if it is perpendicular, this will help to keep the dam in position. And even if there is some leakage along the bedding plane, this water is recirculated in the reservoir. But here what happens? If there is any leakage, the water will go downstream. The purpose of construction of dam itself will be failed. So this is not safe and this is safe. So and here resultant R is parallel to the bedding plane. So there are chances of sliding of the dam because of this resultant force parallel to the bedding plane. So this is how, this is one example in case of dam. Similarly, these bedded rocks are important when you construct tunnels, roads, okay, any type of construction. These play a very important role. So today we are going to solve the problems based on this dip and strike. So let us understand first what is mean by dip and strike. So what is dip is, so these beds have become inclined. Okay, so this angle of inclination of the bed, so these are the beds, you can name them as 1 2 3 4 like that. Okay, so here 4 is the older bed and 1 is the younger bed. So these beds are dipping in this direction, so this is the dip direction. And here this is the horizontal plane. Okay, this is the horizontal plane, it is a imaginary plane. So what is dip is the angle between the bedding plane and the horizontal plane. So the angle between these two planes is called as the dip angle, and the direction in which the beds are dipping, that is the dip direction. Okay, then what is mean by strike? Strike is the trend of the rock or the direction of the line which is formed by intersection of the bedding plane and the horizontal plane. So this is your horizontal plane and this is your bedding plane. So where these two planes are meeting along this direction. So this is the line of direction. Okay, so the direction of the line which is formed by intersection of the bedding plane and the horizontal plane, that is called as the strike. So I hope the idea of dip and strike is clear. So dip is the angle of inclination and strike is with respect to horizontal plane, that is important, and strike is the direction of the line which is formed by intersection of bedding plane and horizontal plane. So we'll solve the problems based on this. So the line on the ground or the thread of the cross, that is called as the strike. So that strike in geology is the direction of the line which is formed by the intersection of the bed or the other planar features and the horizontal plane. So where the bed and the horizontal plane intersect, that line is called as the strike line. Then the next concept is your dip. So dip is the angle or acute angle that a rock surface makes with the horizontal plane. Means the angle made by the bedding plane with the horizontal surface is called as the dip of the bed. So it is further divided into true dip and apparent dip. So let us understand what is true dip and apparent dip. So this dip, that is, it is 90 degree to the strike or perpendicular to the strike, that is called as the true dip, which is always 90 degree with the strike line. That line or that direction which is 90 degree to the strike is called as the true dip direction. Then other than true dip, all the directions they are called as the apparent dip directions. So it may be either more than 90 or less than 90. So other than 90, all the directions other than 90 degree, they are called as the apparent dip directions. So this concept is very, very important to solve the dip and strike problems. So dip and strike. So true dip is always 90 degree. You have to remember 90 degree to the strike line. So all these are apparent dips, and the 90 degree to the strike is called as the true dip direction. Then the relation between the true dip and strike line is they are always perpendicular to each other. This is very, very important. That is, relation between the true dip and the strike line is they are perpendicular to each other. That means it is 90 degree. True dip is 90 degree to the strike line. Now we will begin with the problems. So there are four different sets of problems. So we will see one by one. So just see what is given in the set 1. So in set 1, the amount and direction of the dip is given. We need to determine the amount of apparent dip in the given direction. Means here, what all things are given? The amount and direction of dip is given, as well as the apparent dip direction is given. We need to find out the amount of apparent dip in the given direction. So that is the aim of the first set. So there are 3 examples in the set 1. So the problems are given as 1.1. From set 1 was problem, from set 1 second problem and third problem. So we will discuss one example here. That is the first problem. A great bed dips at the rate of 1:6.5 in the direction due north 10 degree east. here what is given? The direction and amount of true dip is given. That is, the direction is north 10 degree east. Along that direction, the amount is 1 is to 6.5. Then what is asked? What will be the amount of apparent dip in north 60 degree east direction? And also we need to find out the strike direction. So here along north 60 degree east, what is the amount we have to find? So it's very easy. So we'll see first what is given data. Apparent dip direction is given, that is north 60 degree east. Along that direction we are going to find what is the amount of apparent dip. Then that is apparent dip amount we are going to find out. Then the true dip direction and true dip amount is also given. Then we need to find the strike direction. So first we will begin with these problems. So how to solve these problems is, first with the exact measurements we have to draw the north, south, east, west line meeting at point O. Okay, are you ready? You have to draw exactly perpendicular two lines with the help of set square. Okay, that is exactly 90 degree. The two lines we have to draw, that is north, south and east, west direction. That line is meeting at point O, that is the origin or center of that line. Okay, so then first we will mark the given angle. So there is a great bend which is dipping at the rate of 1 is to 6.5 in north 10 degree east. Means how to measure the angle is, from north it is 10 degrees east. Means from north line we are going to measure. So keep the protractor on the point O on the north direction. Then from north measure 10 degrees towards east. So we will solve the problem. Okay. So this step we have done. That is the drawing of north, south, east, west line meeting at point O. Then see here we have to draw north 10 degree east direction. That is nothing but the true dip direction. Then what is the amount given on this direction is 1 is to 6.5. Means along that line from point O we need to measure 6.5 centimeter distance. So that is your true dip amount. Okay. So what we did, first we have drawn the north, south, east, west line meeting at point O. Then we have marked the true dip direction, that is north 10 degree east, and along that line we have marked 6.5 centimeter distance. Now this is the true dip. Now we know the relation of true dip and strike. How will you find out the strike direction if you know the true dip? So the relation here we are going to use is true dip is always perpendicular to the strike. So what we will do, how to draw the strike line? We have to draw a perpendicular line which is passing from the distance 6.5 what we have measured in that point as A, name it as A. So from point A we need to draw a perpendicular line to OA. So this is a, we have to draw the perpendicular line to OA. Okay. Now what is next given? So this is the true dip and strike. Then next what is given? North 60 degree east direction is given. So you can draw this line parallel which is passing from O. That is nothing but the strike line, and you can measure the angle between the north and the strike and south and the strike. So I'll is that the apparent depth direction, that is north 60 degree east. So and measuring angle is very very important. Always we need to remember that we are going to mark the angle from north, taking north as 0 towards east we are going to count. So from north is 0, 10, 20 and up to 60 degrees we are going to mark. That is the given apparent depth direction. Now this line of north 60 degree east, where it meets the straight line, that point is the required answer. That you can name it as B. Okay. So how we got the point B? We have drawn the apparent direction north 60 degree east, and where it meets the straight line, that is the amount in the given direction, that is north 60 degree east. So if you measure the distance OB, okay, so that is the required apparent depth amount. Okay, so this is the first problem we have solved. Then the last straight direction, how to measure? See here, the same straight line, we have to draw a parallel line. We have to transform this line, parallel line we have to draw, passing from the origin O. Okay, and measure the angle of that straight line from north. What is the angle towards west? And from south, what is the angle towards east? So always we have to remember any angle which is in the first and fourth quadrant, we are going to measure from north, and angle between any angle in second and third quadrant, we are going to measure at the down angle, we are going to measure taking south as 0 and top whatever angle we are getting, that we are going to measure as north as 0. Okay, so from south, what is the direction? From north, what is the direction? We will measure, and that is the straight direction. So here we have used 1:1 scale, that is 1 unit is 1 centimeter. So this is how we are going to solve all the problems. Okay, so here we have to write down the results also. So what results we got? The apparent amount, that is you have to measure the distance OP, and we have to write it as 1:10. And straight direction, that is the angle of the straight line, that we have to measure and write it as north 77 degrees west and south 77 degree east. So both the angles we need to write to show the straight direction. Yes. Did you get the answer? Hello.
Yes, ma'am.
Yes. Can you share the screen? Any one of you, Amrut?
Yes, ma'am.
Yes. What answer you got?
Ma'am, OB 10.1
Yes.
and angle 80 degree, ma'am.
Yes. Fine. No problem. Plus or minus 1 is fine. So your answer is correct. You have drawn the lines correctly. I hope everyone has got the correct results. Okay, then we'll move on to the next problem. First problem. Then 1.2 you can solve on your own. Now I'll solve 1.3. Okay. So 1.3, what is given? Just see, there is a gold vein which has a true dip of 1:4. There is a gold and amount is given, that is north 60 degree west and amount is 1 is to 4. So we will see again how to solve the similar way. First draw a north, south, east, west line meeting at point O. Okay, exactly perpendicular. We need to draw it. Then first measure the true tilt direction, that is north 60 degree west. So from north and 0 towards west, we are going to measure the 60 degree towards west. From north and 0, 10, 20 up to 60 towards west. Don't go wrong in measuring angles. So measure the angles properly. So north 60 degree west is the true dip direction. Now what is the amount? 1 is to 4. So we will take the distance OA, that is 4 centimeter. Okay. So that is the 4 centimeter. We will give it name. We will name that point as A. A, how we got the true dip amount, that is along north 60 degree west. The amount is 1 is to 4. So here it is 4 centimeter I have marked. Okay. Then what is the next step? We need to draw a straight line which is perpendicular to OA. Okay, because OA is our true dip. So true dip is always 90 degree to the straight. So we have to draw a perpendicular line to OA from point A. So this is the perpendicular line to OA, that is 90 degree. Okay. Now we will transfer that line. We will draw one more line here which is parallel to that straight line. That is the straight line. Okay. Then what is the required answer? We need to find the apparent dip amount in the given direction. So what are the given direction? Due north. What is the amount? Then we have to mark north 80 degree west. So remember, from north, taking north and 0, we have to measure towards west 80 degree and draw a line. Then due west, what is the amount we have to find out? So this is how we are going to proceed further. So this is the apparent dip direction, that is north 80 degree west. Now what is the required answer? Where the straight line is meeting the point B, point C and point D. Okay, that is due north 80 degree west and due west. So this is the required answer. We are going to measure the distance OP, OC and OD to get the apparent amount. So this is the first set, how to find how to solve the dip and strike problems. Okay. Then the final answer what you have to write is the strike direction you have to measure. So strike direction is the angle between north-south line, north-south-east west line and the strike line. So here the strike line which we have drawn is at making angle. Okay. That is north 30 degree east and south 30 degree west. Opposite angles are equal. So we can write the same angle, that is from north it is 30 degree towards east and from south it is 30 degree west. So this is the way we have to write the answer for this. Yes, understood the problems.
Yes, ma'am.
Yes, ma'am.
So can anyone share the third problem what you have solved? Share your screen. Nihal,
Yes, ma'am.
please share your screen.
Okay, ma'am.
On the camera.
OA is equal to 4 centimeters, ma'am. OA is equal to 4
You are not able to share the screen.
ma'am, it's getting problem.
Okay, fine, no problem. You can tell the answers. Yes, Amrut.
Ma'am, OA is equal to 4 centimeter, OB is equal to 4.2 centimeter, OC is equal to 4.6 centimeter, and OD is equal to 8 centimeter.
Yes, correct. So like this, we have to solve the remaining three sets. In the next lab, we will try to cover all the three sets. So we'll stop the meeting today. Thank you.
Thank you, ma'am.
Thank you, ma'am.